A new lunar lander just recorded a total lunar eclipse from on the moon. How did that video get back to Earth?
In multiple hops. This probe, the Blue Ghost 1 by Firefly, has on it 3 S-band antennas, that's somewhere between 2 and 4 gigahertz, and 1 X-band antenna, somewhere between 8 and 12 gigahertz. And these antennas stream the video up to an orbiter going around the moon. And it picks up the video signals, and then it retransmits them back to Earth where we receive them.
Why 2 hops?
Aha! Because all of this is a warm-up for the next mission, the Blue Ghost 2, which they're going to leave on the far side of the moon, where it has no path back to Earth, so that they can put some of the most sensitive radios ever built there, picking up the radio noise of the universe with no interference from Earth, because the moon will be in the way, shielding them from all of our radios. So there'll be no way for it to get radio back. So it'll collect the signals into big files, and then as the orbiter comes by, it'll beam them up to it, and then when it comes around the other side of the Earth, it'll beam it back to Earth. And that's the way we're going to get these signals from the universe that can't be picked up on Earth. This radio telescope is called the Lunar Surface Electromagnetic Experiment, LuSEE-Night. I think there's some sort of Beatles reference hidden in there somewhere. But the idea is that it will be able to pick up these radio signals from far earlier in the universe's past. It's going to tune for the outside edge of the universe and see if it can hear things close to the Big Bang.
So what's the protocol it's using to talk to that?
So there's actually a third radio on the probe as well. This is a 70 centimeter radio. So we're talking 430, 440 megahertz UHF, lower frequencies from our modern point of view. So it's not a really high speed radio, but it runs Proximity 1 Space Link protocol. So this is a protocol made specifically for landers to talk to orbiters. When they drop probes on Mars and have orbiters around there, any other probes in the future that they drop on the moon to talk to the orbiters there, they've now got a standard protocol for talking to your orbiter when you're a lander. It's a product of the CCSDS, the Consultative Committee for Space Data Systems. And this is an organization that consists of members of the space organizations from every country that's in space today. So not just the US, but in fact, Italy, Canada, France, China, Germany, the ESA, Brazil, Japan, Russia, and the UK. A lot of these countries you think of as competitors, but they're actually working together to make sure that their space technologies are compatible. It's really hard problems. It'd be really good if other countries could act as repeaters and things like that, right? The US isn't always facing towards the moon, so you need to be able to ask other countries if you can use their radios. It's good if things are compatible. And so they're all working together to set common standards for talking to satellites, talking to orbiters, talking to spaceships.
So what is the X-band used for?
So X-band is pretty high frequency for radio waves. It's 8 to 12 gigahertz, and it's used for a lot of space stuff. You can get a nice wide signal and reserve for these space things. So in fact, Starlink uses it. Most of the time, your Starlink is coming down at 12 gigahertz. You have permission to go up to 30 gigahertz, but kind of same ballpark. NASA uses it with those huge dishes to talk to things like Voyager and the Mars probe. A lot of that is in this 8 to 12 gigahertz band. And so the probe on the surface of the moon is using that to actually stream the video back to the orbiter.
Cool.
Yeah, it is cool.
So what about S-band?
Well, S-band is 2 to 4 gigahertz, which is much less exotic, right? I mean, normal old-fashioned Wi-Fi here is 2.4 gigahertz. Those are S-band radios. So we use it a lot on Earth. It's a very busy band down here. But of course, you get to the moon, not a lot of Wi-Fi to interfere with you, so it becomes a safe protocol to use to talk to other things on the moon.
Should they be using Speedify up there?
Well, so Speedify, of course, has this amazing ability to take every internet connection it can find and combine them into a faster, more reliable internet connection. So all that sounds like things they would want, right? But they're running these proprietary protocols. These are not internet connections, these CCSDS links running proprietary protocols. If there's demand, I'm sure we could put Kevin on it and get a new version of Speedify that works over Proximity 1. But at this second, no, we do internet, and this is space protocols.
Yeah, Kevin could do it.
Oh, absolutely. Give him the weekend.
Yeah. That's it. If you like this video, make sure you subscribe for more tech discussions like this one.